Hello everyone, welcome back to this Beckhoff TwinCAT 3 motion control series video. And in this video, I will mainly discuss how can we use MC Move Relative and MC Move Absolute, these two motion control, position control function block to control my actual hardware step motor with encoder. This acts as position control closed loop system. And in the previous video, I showed how can we connect our function block control to this axis. The key setting that comes from this link to PLC. Using this variable, this is single axis, this is the variable name, and we declare this single axis name from this GVL single axis REF, this date type. And once we declare this, go to axis, link this variable at this link to PLC. So this variable will run as a bridge, connect our function block and this axis we set up. Then go to program, at every function block. So at this axis here, we connect this variable date type that is axis underscore REF. So this allows the function block know which axis configuration we configured before and which axis is controlling. Okay. And in the previous video, I showed how can we use reset, power, home, jog. That's home is a very simple direct give a 0 and move velocity. And keep in mind for the move velocity, once we trigger, it will run. And to stop this axis, we have to use MC halt or MC stop. And in this video, I will mainly show the position control using the move absolute and move relative. Meantime, to show the position and the velocity, I will use the trend or plot curve to show the velocity and the position value. Okay, let's firstly quickly demonstrate this motion. So firstly, don't forget, download your hardware, active configuration, and download the program. Now I'm using my laptop run as a controller, and I'm using the BK1120. This Beckhoff EtherCAT, this interface module, and I'm using the KL2541 control my step motor and use the incremental encoder as a feedback. Okay, and to monitor the actual velocity and the position, we can go to PLC, Windows, and click this watch one and drag these two tags. One is actual position, NC to PLC, one is NC to PLC dot actual velocity. Now the position initial, that is 0. Okay, velocity also 0. Now we enable the axis. So go to the power, we enable the power, give 100% override, and enable the positive and the negative the direction. And now this axis is powered. And then go to the move relative. And move relative, let's set 360. Because one revolution I set 360 millimeter. That means 360 millimeter represent one revolution. So for the relative control, I set 360. That means every time we trigger this command, the axis, this motor will run one revolution. Okay, and the velocity, we can set a velocity speed. For example, we can set 300. Okay, and then the acceleration and the deceleration, I will leave a 0, the default. 0 here means we will use the default value. That default value we set from this axis. Don't forget from this parameter here. So the default acceleration and the deceleration, it will use this. 400 here, that's not a big value. So we will see the axis will ramp up and ramp down. Okay, so we set 360 as a relative distance. Then let me trigger this axis. Trigger. Okay, it ran the one revolution. Now this axis gets 360. Okay, if I trigger again, it will travel to 720 because that is a relative move. So every time I trigger, it will based on the current position and travel the relative distance. That's 360. Now it at 720. Okay, if I trigger it again, it will get 1080, this position. Okay? This is the move relative. And let's go to the move absolute. Now the axis is at 1080. If I set 0, this motor will travel back to the 0 position. Okay? And velocity, we can set a high speed. For example, I can set 400 millimeter per second. Okay? And I will use the acceleration and the deceleration. Probably we can set a little bit higher. For example, I can set 800. Let's try. Let's see the difference. So this time we can see the speed can be ramped up very quick. Okay? We go back to 0 position. 0.0, that position. Okay, trigger. Meantime, we can watch this speed. Okay, it run around 400. Now it get a 0.0, this position. Okay, and we can travel to, for example, let's say 800, this position. We set and it's waiting for the trigger. So keep in mind that is trigger. Meantime, we can watch this active and the busy signal. So we trigger. So while the motor is running, these two signals that turn on. And once the motor gets this position, they will drop. Meantime, this done signal will turn on. If our trigger signal take off, watch this done signal. So the down signal will go off if it's done before. Okay, so let's watch again. So this time, let me travel longer. For example, 2000 this position. Trigger. And before it gets that position, I will pick off this command. So it will still traveling till it gets that position. Once it's got that position, busy active will go off, and down signal will turn on 1 cycle, the program cycle. If this execution command is still on, this down will still on. Sometimes we will use the down signal, turn off this command. Or sometimes use the sequence control. Once we get this done, take off this command and then move to the next move command. This is the basic idea. Okay, in the actual case, sometimes we will use the sequence control, control the different command, use the sequence, transfer the different position command. Or we can call multiple times, use the different, the instant DB, and call different move absolute command. That time we can prepare the pre-configured position for each move absolute command and then trigger the different function block. Then we can see the axis can travel to different position. And in the meantime, to facilitate our commissioning, we can set up the train. Now let me show how can we set up the train. That is a very convenient tool. So from our project file, click project. And firstly, I highly recommend when you set up the train, you better set up this project the same directory with your project. Keep in mind, to find out this project directory, as you can see here, we can now know what the current directory this project locates. So you can do this way, right click this solution here, select this open folder. Then we will know for this solution and the PLC project, what the directory it locates. Okay? And then let's use the same directory. Copy this directory. Paste here. Okay? And we can set up this name motion plot. And then don't forget, we select this TwinCAT measurement and select this YT scope project. Y means the value, T means the x-axis, that is the time. And here we can select create a new solution or add to solution. Prefer use the add to solution, so this measurement project will attach within this solution. Okay, let's click OK. Then we will find here this measurement project will be attached under this solution. And now from this train, we can grab the same variable, this position and the actual velocity. Okay, so firstly, let's browse this data pool. Right click, click this target browser. So it will show the controller this project can connect. So because I'm using my laptop as a controller, so now it can see my local this computer. If you are trying to connect one controller that is not your laptop, so probably you can click this add or remove ADS routers. And from here, click this add, type in the IP address, and this is similar as we set up the communication from the TwinCAT to the controller, right? And then you will find, so this browser can find that controller, select the green controller. That means this browser can find, and expand that. And then go to 851. 851, that is this PLC, this address number. And then let's go to this global page. So keep in mind here, GVL_SA, that is the global variable list here. This is the page name. And then let's find out the access, single access, that date type is access_ref. Okay, and then let's drag the NC to PLC and find out the actual position here, and then drag to here. So we drag to here. Also, let's drag the site velocity as well as the actual velocity. So this is set velocity. Drag to here, and let's find out the actual velocity. Okay. So this is the browse. And after we find the tag, drag to here. And then let's go to YT chart. So the YT chart, one chart means this is the one screen. It has an X and Y. If we need to set up different Y axis, so we can right click, click this new axis. Because we have a position Y value and the velocity Y value, we need two Y axis. So for example, we can rename this to value position. Okay, and we can rename this is the velocity, value velocity. Okay, and then let's drag the set and the actual velocity to this axis, and drag the actual position to this axis. Okay, so this is the one chart. If you try to set up the different chart, so you can go to the scope project here, right click, click this new YT chart. So we can see you set up the new chart, and then you can set up the new axis. Then you can create a new chart here. So this is a quickly demonstrate. Okay, in this case, one chart with two different y-axis, that's enough for us. Okay, and this actual position I can change to different color. So I can click this property at the right side. I can change to, for example, let's switch to red color. Okay, switch to red color. And in the meantime, this y-axis, we can set the range of the y-axis. We can manually set up the max and the min. For example, we can set up this value position. Let's set up the maximum, let's say 1500. And the minus position could be minus 720. So this is the minus 2 revolutions. And after we set up this, don't forget this is scale mode. So by default, it will be the automatic grown. So this y-axis will follow the value. Most of the cases, we will select this auto because at the beginning, while we are testing the system, maybe the y-axis is hard to set up properly. But sometimes if we try to hold the max and min of the y-axis, probably we can set like this. So I can switch to manual. So we can see now this position y-axis, it can set like this. We will leave the speed value as automatic. Okay, if I click this speed, this velocity, that is the auto grow only. Okay, and this is the position. Okay, and this is the speed velocity. All right, now let's turn on the axis and let's move back and forth. And meantime, we can turn on, start, record this chart, and we can see the train. That plot is changing there. Okay, so I can float this chart, leave it here, and let's start. Okay, now the axis is at 0. Let's go back to 0 first. So let's set 0 and trigger this axis go to 0, right? So let's travel to 0 first. Okay, so now we are at 0. Let's turn on the start record. Okay, it's recording, so we can see the line. Okay, now let me trigger. Let's travel to 1000 and trigger. Okay, it get 1000. Then let's travel back to 0. Then let's do the relative move, the 300 velocity. So now I will trigger. Then let me write the minus. Let's do minus 1000 travel. Okay, and the trigger. Speed, let's travel a higher speed. Now let's travel to 600 the speed. Okay, we did couple motion. Now let me stop this record. Turn it back. Okay. Okay, we can click this max, so it can give us an over picture during our recording. So we did a couple times motion. From this right line, if you record, the right line, that's the position. As we can see, the position control, that's the actual position, is pretty smooth. So we can zoom in, or we can enlarge here, so we can see this curve, this position value shows there's no jerk there. So that means our K value or some parameter optimization is just fine, because this position, it doesn't have any jerk or vibrating there. So for the mechanical things or for the motor motion, that looks fine. Speed, it shows vibrating here, might be the encoder, the filter of the encoder, we can set, increase that filter a little bit. The blue line, that's the actual. And you can see this set velocity, this is the axis internal setting. So the blue line, that's the actual speed, that should follow the setting, right? So we can see the tracking. This following looks fine, but this speed vibrating, that vibrate basically 50 millimeter per second. That means this encoder signal, might be we need a filter on that, or maybe this encoder actually should be mounted. Because in my case, as we can see, my encoder is just behind the motor. While this wheel is moving, this encoder directly measures this moving. If there's some vibration here or some noise, definitely this encoder will give us this noise. In the actual case, basically the encoder will be mounted at the low side. So that could be better than this. Okay? So at this curve, we can see. First, let's watch this actual position. So this red curve record where it got travel. Now we are at minus 640. So that's why this red curve stopped at this minus 640, this position. And the blue curve record which speed that time For this third motion, that time the speed was slow. This acceleration and deceleration can give us a sense, say, for example, the last motion, that acceleration I set high. I remember that's 600. So this curve can help us to watch the actual position and the speed setting, even some optimization issue. For example, for the optimization, so now we can see every stop, this curve looks smooth. If I change the K parameter, for example, if I go back to the axis, let's go to control. Now the KV, now I set 4, and the moving, that is 10. If I decrease this standstill K, for example, I shrink to 1.0. From 4, shrink to 1.0. We will see the stop position might have some overshoot. So now let's go back. I will record a new line. Don't save the value. Now it's recording, so I will float it. Go to the program. Okay, now let me set a new position. Let's travel to a positive, for example, travel 720. We travel 600 this velocity, and then let's travel to 0 position, travel back with a 400 velocity. And then let's travel to a new position, for example, 780. With a 400 velocity. That's our overall picture. So this is 3-time motion. So from this corner, let's zoom in. So this time we can see for this curve, this position curve, because we decrease the K, that ability to control the axis will be decreased. So we can see it got a vibrating here. It's not perfect smooth, right? And also we can go to the second move. So at here we can see this position, it got an overshoot and turn it back. This is not quite good in the actual case. That means the mechanical things will move to the target and then go back a little bit and then go to this position again. It will show the hesitate and the vibrating there, right? Especially for this case, we can see it go there, go back, and then it adjusting the axis, right? So this curve can be also used to optimize our parameter. For example, if this is the first time we see this happens, that means we need to optimize our axis. And now if I go back to control, I increase this KV, this standstill value, go up to 5.0, for example, and download. And then let's do the travel again. Start this record. And then I will control this position. Let's use this absolute control. Let's travel to back to 0. And let me set the 780 again. Let's travel back and forth 1 time. And then let's see that curve. So we can see this time the curve shows much smoother than last time, right? I stop this recording. So we can see this curve. So now the K value for the standstill that we increased from 1 to 5 now. So it becomes much better. So this curve also a very convenient tool when we optimizing this control loop for speed and precision. Alright, that is using the function block, the move relative and the move absolute to control the axis. Also the YT scope. This measurement tool is a very convenient tool for us to monitor the velocity, precision. Sometimes we will also monitor the actual torque or other values from the axis. Alright, that's it for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.